Hi, and welcome to a brand new video. So today what we're going to do is tackle this problem on the screen where basically you have a tree and you need to iterate through the tree so that if two nodes in the tree add up to a target number, then you return true, otherwise you return false. So you might expect that we have to do some sort of if we didn't have a binary tree, we just had like a list of numbers or something, we would iterate through two for loops and see whether array of I is equal plus array of j is equal to k. That's what you would think. But that actually takes n squared time, and there's a way that we can cut that down. So what we're going to do is we're actually going to do a little backwards. We're going to say we're going to take a root, let's say n, and we set its root dot val to, let's say, I don't know, I. So if k minus I, this is going to be equal to some sort of value, right? So if value exists in root in the tree, then we return true. Else we return false. And we just need to do OR of all the tree nodes. So in order to do this, what we're going to do is we're going to create a list. And list integer list. This list here is going to keep track of all the previous values that we've already encountered. And that will be helpful for this part because if we have let's say that we have 5 and 3 and the target is 8. So if we encounter 5, we don't see 3 yet in the tree, but once we add 5 to the array and then we get to 3, then 3 encounters 5, right? So then we were able to return true in that scenario. So we're going to instantiate this list. And then we're also going to instantiate k. And the reason is so that we don't have to keep passing it inside a recursive function, just so that we save some space. And then do private boolean recursive tree node root. And here we basically have two scenarios. So what we're going to do is we're going to say if list.contains num minus root.val, then this is our answer, right? So we're just going to return true. And you can actually do that without the parentheses there. And then otherwise what we're going to do is we're going to do list.add root.val, and then we're going to create a variable, let's say bool. We're going to set to false, and it's not val, it is boolean. We do if root.left is not equal to null, bool is equal to bool or recursive of root.left. And if root.right not equal to null, bool equal to bool or recursive root.right. And we just return bool. So what essentially we're doing is that if list.contains that other value, you return true. I don't know why I wrote false there. And then we add that value to the list if it isn't, so that maybe in the future we can catch on that number with its other. And then we use this variable boolean to see whether it's true in recursive.left or recursive.right, and we just return boolean. So now all we need to do is return recursive of root. And if you run this, you can see that we get true with the first scenario on our sheet. So just to kind of reiterate, what we did was that we saw whether the part that we already iterated through the tree had not the target minus the current value, and if it did, we return true. Otherwise, we would iterate through the left and right and see whether it's true there, and then we return what we got. So hopefully this video was helpful and see you in the next video.